Alright, to the next module of stationary waves. In this module, we are going to study about the numericals which are based on the concept of beats of an organ pipe. To further study that, let us see the problem that is given to us. Two tubes are there which are having the length 50 cm and 51 cm. Closed at one end, produce 7 beats in 2 seconds. When sounding with their fundamental notes, that means we need to consider only fundamental notes. Neglecting end correction, that means we will not be considering E. We need to find out the velocity of the sound in air. So to find out the velocity of the sound in air, let us see what is given to us. First, beats per second are given to us, but in the question it is beats per 2 seconds. So beats per second will be 7 divided by 2. Again, we have been provided with the length, so I'll write the length of the first tube is 50 cm, with the second being 51 cm. So I've got the length of the tube which is given to us. What do I need to find out? I need to find out the velocity of the sound in air. And what is the formula that we are going to use? That is N is equal to V upon 4L. Also, this V upon 4L is a concept that we need to remember because it is only the fundamental notes or the fundamental frequency. So to solve this problem, let us see how do we go ahead. Can I say for the first tube, N1 will be equal to V by 4L1. Also for the second tube, N2 will be equal to V by 4L2. On dividing equation 1 and 2, I get N1 by N2 which is equal to L2 by L1. Can I say N1 by N2 will now be L2 by L1, that is 51 divided by 50. So can I say N1 is 51 by 50 N2? Now I know that since length 2 is greater than length 1, the frequency 1 will be greater than frequency 2 because the relation between length and frequency is inverse. So can I say N1 minus N2 is 7 upon 2, that is 3.5. I also know that N1 is 51 by 50 N2. So substituting that in this equation, I get 51 by 50 N2 minus N2 which is equal to 3.5. On solving this, I get 51 N2 minus 50 N2 which is equal to 3.5, and on the left hand side it was divided by 50. When I solve this, I get N2 which is equal to 3.5 into 50, that comes out to be 175 Hertz. Now students, this is the second frequency that we have got. Now I know that N2 is actually V by 4L2. So can I say alone V will be 4 N2 into L2? I've got 4. I've got N2 that is 175 and L2 that is 51 centimeter. So I'll write it as 51 into 10 to the power minus 2 meter. On solving this, I get the answer as 357 meter per second. Now this is the final velocity of the sound in air. So students, with the help of this module, we studied the concept of how to get the velocity of sound in air with the help of the concept of organ pipe. So this is it for this module. We will be meeting you in the next module. Thank you.